In the company legend, this is how it begins. Sometime in 1978, late at night on a road outside the Osaka R&D Center in Japan, an exhausted engineer named Shoichiro Irimajiri is driving home after another grinding day. He stops at a red light. Behind the traffic signal, fixed to its post, is a plain oval board. Irimajiri stares at it. He has spent weeks trying to solve an engineering problem that nobody in the history of motorsport has cracked. How to fit the breathing capacity of a V8 engine into a cylinder block that the rules say can hold only 4 cylinders. The two-stroke engines dominating Grand Prix motorcycle racing make roughly 120 horsepower from 500 cubic centimeters, and they do it with a mechanical simplicity that borders on unfair. To match them with a 4-stroke, Honda needs massive valve area, and massive valve area needs a piston shape that has never been manufactured for any racing engine on Earth. The oval board behind the traffic light gives him the shape. From that moment forward, Honda will spend 5 years, consume millions of dollars, and burn through the careers of its brightest young engineers attempting to make an oval piston work at 20,000 revolutions per minute. The machine they build, the NR500, will never score a single world championship point. But what it teaches will be worth more than any trophy ever cast. You're watching Motorcycles and Engines, where we take apart the machines and the companies that built them, down to the crankcase and the man who poured it. If that's your kind of story, subscribe and hit like, because this machine lost every race it entered and still changed everything that came after it. To understand why a Honda engineer was staring at a traffic sign for the shape of a piston, you have to understand what Honda had already proven and what it chose to walk away from. In the 1960s, Honda did not merely compete in Grand Prix motorcycle racing, it dominated with a ferocity that the sport had rarely seen. The engines were 4-stroke works of art, twin-cam, multi-cylinder designs that revved higher and produced more power per cubic centimeter than anything Europe's established factories could answer. By 1966, Honda became the first manufacturer in history to win all 5 solo classes of the World Motorcycle Championship in a single season. The 50 cubic centimeters, the 125 cubic centimeters, the 250 cubic centimeters, the 350 cubic centimeters, and the 500 cubic centimeters, all Honda. Mike Halewood won the 250 and 350 titles and came within a single tiebreaker of taking the 500 from Giacomo Agostini on the MV Agusta. By the end of 1967, Honda had accumulated 138 Grand Prix victories across all classes, and then the company walked away. Honda withdrew from Grand Prix racing after the 1967 season to focus on building automobiles and mass production motorcycles. The absence lasted 12 years. During those 12 years, the 2-stroke engine conquered the 500 cubic centimeter class completely. A 2-stroke fires on every revolution of the crankshaft, not every other one like a 4-stroke, which means more power events per minute from a lighter, mechanically simpler engine with no camshafts and no valve train to manage. MV Agusta, the last 4-stroke holdout in Grand Prix racing, withdrew in 1976. By the late 70s, Yamaha had won the 500 cubic centimeter world title with Agostini. Suzuki had won it twice with Barry Sheene. And every competitive machine on the grid trailed blue smoke and burned pre-mixed fuel. The 4-stroke Grand Prix motorcycle was extinct. Soichiro Honda despised 2-stroke engines. He called them bamboo tubes and loathed their noise and their oil-fouled exhaust. Honda was a 4-stroke company to its foundation, and every senior manager who had risen through its engineering culture shared that conviction. So when President Kiyoshi Kawashima announced Honda's return to 500 cubic centimeter Grand Prix racing in November 1977, the internal mandate was unambiguous. Honda would return with a 4-stroke. The stated goal was to win the World Championship within 3 years. The problem was that the rules had changed during Honda's absence, And those rules would shape the most ambitious and most humiliated racing engine the company ever built. The regulation that defined the NR500 was the FIM's cylinder limit for the 500 cubic centimeter class. No engine could use more than 4 cylinders. For two-stroke manufacturers, this was barely a constraint. For Honda, it was a wall. To match 120 horsepower, from a 4-stroke, the engineers needed extremely short-stroke cylinders spinning at 20,000 revolutions per minute or higher, and 4 conventional round cylinders simply could not flow enough air and fuel to sustain combustion at that speed. Honda needed the valve area of a V8. The rules gave them 4 cylinders. The gap between those two facts was where the Oval-Piston was born. In 1978, a new department was created at the Osaka R&D Center and given the designation NR for New Racing. The initial team consisted of 3 young engineers, none of whom had ever worked on a Grand Prix motorcycle. Takeo Fukui was named project leader. Suguru Kanazawa took charge of the engine. Satoru Horike was given the chassis. Guiding them was Irima Jiri, the veteran who had designed the RC1666 6-cylinder 250 cubic centimeter Grand Prix engine in the 1960s, one of the most revered racing engines Honda ever produced. Honda wanted young engineers unburdened by old assumptions, steered by one man who had already pushed a 4-stroke engine further than anyone believed possible. Irima Jiri's concept was this: if a piston does not need to be round, it can be made oval, long enough to accommodate 8 valves across its face, 2 connecting rods beneath it, and 2 spark plugs above it. 4 of these oval cylinders arranged in a V4 configuration would give Honda 32 valves, 8 spark plugs, and 8 connecting rods, the exact breathing capacity of a V8 engine, all housed within a block that the FIM would count as 4 cylinders. The initial target was 23,000 RPM and 130 horsepower. The theory was clean. Making it survive at operating speed was something else entirely. The first single-cylinder test engine destroyed itself every time it passed 10,000 revolutions per minute. The dual connecting rods distorted under load and wrenched the wrist pins out of alignment. The wrist pins themselves, manufactured longer than any previously used in a motorcycle engine, to span the gap between 2 conrods, flexed under the violent forces of high-speed reciprocation. And the piston rings, tasked with sealing an oblong bore rather than a circle, demanded machining tolerances that sat at the absolute edge of what late 1970s tooling could produce. Each solution revealed the next failure underneath it. The team worked with the intensity of people who believed they were building something unprecedented. Toshimitsu Yoshimura, who designed the engine alongside Kanazawa, kept the shattered connecting rods and broken valves from those early bench tests in a drawer in his desk for years afterward. He said they reminded him of the enthusiasm the team carried during development. They also reminded him of a hotel room in Nasu in the dead of winter, where the heating had failed and the young engineers wrapped themselves in blankets while they drew engine layouts by hand, because there was no other place to work and no reason to stop. They finished the drawings. By June of 1979, a full 4-cylinder prototype designated the 0X engine was ready for its first track test at Suzuka Circuit. Riders Mick Grant and Takazumi Katayama climbed aboard. The engine produced 100 horsepower at 16,000 revolutions per minute, 30 short of the target and 20 less than the rival 2-strokes. The 1979 season was already underway. The British Grand Prix at Silverstone was weeks away. The engine was not ready. Honda decided to race it anyway. In August 1979, Soichiro Honda himself flew from Japan to Silverstone to watch his company's return to Grand Prix racing. What he witnessed became one of the most painful moments in Honda's history. 2 NR500s lined up at the very back of the Silverstone grid, both having barely qualified, given reserve entries rather than earning their positions on pace. Soichiro Honda and his wife watched from the stands. The flag dropped. Grant crashed at the first corner when oil leaked from the engine onto his rear tire, the machine sliding across the tarmac, trailing sparks until a marshal ran forward with a fire extinguisher. Grant was unhurt. Katayama lasted 7 laps before the ignition system failed. Both machines retired. Honda's return to Grand Prix motorcycle racing, 12 years in the making, had lasted minutes. 3 weeks later, at the French Grand Prix at Le Mans, the humiliation deepened. While Sheen, Roberts, and Randy Mamola battled for the lead, Fukui, Kanazawa, and Horiki stood in the back of the pit lane, in white overalls, watching a race they were not part of. The NR500 had failed to qualify. The mechanics had worked through the night rebuilding the fragile engines, and it had not been enough. The press gave the machine a nickname that would follow it for the rest of its life. They called it the Never Ready. But what the press could not see was what was happening inside those 3 engineers standing in the back of that pit lane. Fuki was learning how a racing program lives and dies under pressure. Kanazawa was cataloging every failure mode of the Oval-Piston under stresses that no laboratory dyno could replicate. Horiki had watched his aluminum monocoque chassis prove its weight advantage and its fatal flaw in the same weekend. Half the weight of a steel tube frame and completely impossible to service during a race. The NR500 was not teaching them how to win. It was teaching them something harder and slower and more valuable. It was teaching them every single thing that prevents winning. Honda poured 2 more seasons into the NR500. The engine improved steadily. The racing results did not. The machine's fundamental problem was physics, and no amount of ingenuity could fully erase it. The NR500's 4-stroke V4, with its 32 valves and 8 connecting rods crammed into 4 oval cylinders, weighed roughly 20 kilograms more than a comparable 2-stroke engine. The complete motorcycle was about 60 pounds heavier than the Yamaha's and Suzuki's it was trying to beat. On a Grand Prix circuit where tenths of a second separate the grid, 60 pounds is not a disadvantage. It is a verdict. The monocoque chassis had to be abandoned because removing 18 6mm bolts to access the motor during a race weekend was not racing. It was archaeology. Honda introduced a secret night shift, a separate crew spending 10 hours rebuilding engines so the bikes could run the next morning. A Yamaha crew could change a piston in 40 minutes. The original 16-inch Comstar wheels were discarded for standard 18-inch because Michelin could not develop the special tires fast enough. The engineers took to grinding metal off the bike the night before races, scraping weight wherever they could find a surface to remove. It was not enough. 100 horsepower in a heavy chassis with an engine that could barely survive a push start does not beat 120 horsepower in a machine that weighs less, starts easier, and can be torn down and rebuilt between sessions. And then in the summer of 1981, Honda found the one rider who could make the NR500 to do something it had never done. Freddie Spencer was 19 years old, a superbike racer from Shreveport, Louisiana, with hands so sensitive on a throttle that riders 10 years his senior could not explain how he did what he did. In July of 1981, Honda gave him the 3rd generation NR500 at Laguna Seca for what was meant to be a farewell. The company wanted American fans to see the Oval-Piston before it went to a museum. Nobody expected what happened next. Spencer lined up against the reigning 500 cubic centimeter world champion, Kenny Roberts, on a Yamaha 2-stroke that outpowered the NR500 by a comfortable margin. Spencer won the heat race. He beat Roberts on a machine that had never finished inside the top 10 of a Grand Prix. On a motorcycle the world's press had been mocking for 2 years. The Japanese engineers in the pit lane lost their composure entirely, jumping, shouting, running to find a telephone to call Japan. Spencer recalled it later. "You would have thought I'd won the world championship or something." Honda did not send the NR500 to the museum. Within weeks, Spencer was flown to England to race it at the British Grand Prix at Silverstone. On Spencer's first attempt at a push start, He jumped too high and landed on the fuel tank chest first, bruising himself badly. The team practiced dozens of starts until Spencer could fire the engine in 2 big strides. On the circuit, the NR500's lack of torque was almost comical. Coming off the left-hander onto hanger straight, a slight headwind would cause the revs to drop when Spencer shifted. He learned to tuck in every limb, every time. He qualified inside the top 10 and moved through the field to 5th place, running inside the points, faster than the NR500 had ever gone in a Grand Prix. Then the valve springs disintegrated and the engine stopped. That 5th at Silverstone was the closest the NR500 ever came to scoring a world championship point. In its entire Grand Prix career, the machine entered roughly 8 races. Its best classified finish was a 13th by Katayama at the 1981 Austrian Grand Prix. 0 victories, 0 podiums, 0 points. Kengo Kiyama's win at the 1981 Suzuka 500-kilometer race, where the 4-strokes superior fuel economy paid off over distance, remained the only competition victory the Oval-Piston engine ever achieved. But Spencer called the NR500 the best handling motorcycle he had ever ridden. Not the fastest, not the most reliable, the best handling. The chassis geometry, the weight distribution, the feel through corners. All of it worked. It was the engine's bulk and fragility that betrayed everything the frame promised. And this is where the NR500 deserves to be described for what it was, not what it achieved. A 498 cubic centimeters water-cooled V4 with 4 oval-shaped pistons, each roughly 80 millimeters long and 30 wide, sealed by piston rings manufactured to tolerances that advanced the state-of-the-art in precision machining. 8 valves per cylinder, 4 intake, 4 exhaust, fed by twin carburetor throats and ignited by twin spark plugs. 2 connecting rods per piston, 8 in total, driving a crankshaft that spun past 20,000 revolutions per minute, past 21,000, into a region where the distinction between engine and hand grenade was measured in microns. The first slipper clutch ever fitted to a motorcycle, designed to prevent the massive engine braking of a high-compression 4-stroke from locking the rear wheel under deceleration. Inverted telescopic forks, with the stiffer stanchion at the top, an idea so far ahead of its time that machining accuracy had to catch up before anyone could use it properly. Carbon fiber brakes, a decade before the rest of the Grand Prix paddock adopted them. Rising rate rear suspension linkage. Every one of these technologies, rejected or abandoned during the NR500's brief racing career, became standard equipment on the Grand Prix motorcycles that followed. The machine was right about nearly everything. It was right too early and too heavy, and those 2 things are enough to destroy any racer. But the NR500's brilliance was also its burden. Honda had tried to develop too many radical technologies simultaneously on a single machine, and each one drained time and resources from the others. Brilliance on the dynamometer does not survive a push start in the rain when the rider cannot get the engine to fire. By late 1981, Honda faced a decision that cut against everything Soichiro Honda had ever said about engines, and everything the NR team had poured into the Oval-Piston. Shinichi Miyakoshi, a veteran engineer who had designed Honda's motocross 2-strokes, brought Irimajiri a proposal. A 500 cubic centimeter Grand Prix racer powered by a 2-stroke engine. Not a 4-cylinder like Yamaha's or Suzuki's, but a V3, a 3-cylinder design, lighter, more compact, with a narrower frontal area to cut wind resistance. If you cannot beat the 2-strokes, you outthink them from inside their own format. Irimajiri authorized it. The man who invented the Oval-Piston signed off on the project that killed his own creation. Some of the NR engineers were furious. They confronted Fukui directly. They did not want to abandon the machine. They believed they were close. You can read their conviction 2 ways, and honest history holds both readings at once. They may have been right that the Oval-Piston was approaching maturity. They may also have been too close to the work to see that maturity at the pace of engineering is not the same as maturity at the pace of racing. Honda did not have another 2 years to wait. Development of the NS500 two-stroke began in January 1981. A prototype was completed by October, 9 months from first sketch to running engine. In 1982, Honda fielded both machines. The NR500 made its last Grand Prix appearances, while the NS500 began its first. The contrast was immediate and painful. The final iteration of the Oval-Piston engine, the 3X, was completed in 1983. It produced 130 horsepower at 19,500 revolutions per minute. Yoshimura judged it 95% mature. By every measure on the dyno, the Oval-Piston had finally reached the power target that Irimajiri set 5 years earlier. It no longer mattered. Freddie Spencer had won 5 of the first 7 rounds of the 1983 season aboard the NS500 two-stroke. He claimed Honda's first 500 cubic centimeters world championship that year, the goal the company set in 1977, delivered 6 years late and not by the machine they built to deliver it. The 3X engine was shelved without ever turning a wheel in competition. The NR500's complete Grand Prix record can be stated in one line: approximately 8 race entries, 0 victories, 0 podiums, 0 championship points. The most technically ambitious motorcycle ever built for Grand Prix racing was made obsolete, not by its rivals, but by its own successor. Powered by the type of engine its founder despised. But call it a failure, and you miss everything that matters. Takeo Fukui, the young project leader who stood in the back of the Le Mans pit lane in 1979, unable to qualify, became president of Honda Motor Company in 2003 and served until 2009. Suguru Kanazawa became president of Honda Racing Corporation and later ran Honda's manufacturing operations in Swindon, England. Satoru Horike became managing director of HRC. The 3 engineers who failed together at Le Mans ran the company and its racing empire for the next 3 decades. You do not hand the keys to a corporation that builds 20 million engines a year to men who failed. You hand them to men who learned, and the machine itself was not finished. In 1992, Honda released a motorcycle called simply the NR, known to collectors as the NR750, or by its internal code, RC40. It was designed by Mitsuyoshi Kohama, who would later design the RC211V that dominated MotoGP. Its engine was a 748 cubic centimeter 90-degree V4 with oval pistons, evolved from flat-sided ovals to fully elliptical ones with curved long sides, 32 valves, 8 titanium connecting rods, 125 horsepower at 14,000 revolutions per minute, carbon fiber bodywork, an iridium-coated windshield borrowed from fighter jet canopy technology, an underseat exhaust, and a single-sided swing arm that Ducati would later popularize on its own machines. A digital speedometer projected through a series of mirrors so the rider's eyes never had to refocus between the dash and the road. Honda built roughly 300 of them. The price was $50,000, 5 times the cost of the newly released Fireblade. Honda lost money on every single unit sold. They did not care. Engraved on the fuel tank was a single line, the result of a decade's perfection. Today, those machines command $100,000 to $150,000 at auction when one surfaces, which is rarely. The slipper clutch the NR500 pioneered is now fitted to beginner motorcycles sold at dealerships around the world. The inverted forks are standard. The carbon brakes are universal in MotoGP. The RC213V that won the MotoGP championship in 2013 and 2014 carries the AV4 architecture that the NR500 introduced. Kanazawa asked whether the Oval-Piston would ever return, offered something that sounds like a prayer and a threat in equal measure. Maybe Oval-Piston is stopped now. It's only sleeping. If we have a circumstance of getting the Oval-Piston, we will produce it again. Horike, given the last word by an interviewer who expected regret, offered none. "I don't think the motorcycle was a mistake," he said. "This was a success." On a dark road near Osaka, sometime in 1978, a tired engineer stared at an oval shape behind a traffic light and saw the future of a piston. That piston never won a Grand Prix. It never scored a point. It never proved that a four-stroke could beat a two-stroke at the same displacement in a fair fight. But it trained the men who ran Honda, pioneered the technologies now standard on every elite racing motorcycle built, and produced the only production road machine in history powered by oval pistons, carrying on its fuel tank the quiet, earned boast of what 5 years of failure had actually built. The oval piston never won. It only taught. And the machines it taught are still winning. If you have ever seen an NR500 behind glass in a museum, ridden an NR750 on the road, or held one of those oval connecting rods in your hand, drop a comment below. Tell us the machine, the year, and what it felt like. The people who touched these engines know more about what Honda built and what it lost than any spec sheet will ever capture. Subscribe so you do not miss what we are building here. We are documenting the machines and the people behind them, bolt by bolt and year by year, before the stories disappear. We have the story of another machine empire coming next, and you will not want to miss how it ends.